Okay, so I think we can now switch to the first invited plenary talk at this conference. So our speaker will be Galit Shmueli, and I want to use the opportunity to briefly introduce her to you. So Galit Shmueli is a professor at the Institute of Service Science at the National Tsinghua University in Taiwan. She is the editor-in-chief of the new Informed Journal on Data Science. She also authored multiple books and over 100 publications. And her research interests are in statistical and data mining methodology with applications in information systems and healthcare, and an emphasis on human behavior. And I think at this point, we reach the topic of her today's talk, because this talk is about improving prediction of human behavior using behavior modification. And yeah, before I give the word to Galit, a short note to the audience. I think Murat already said it, but just to be sure, if in the end you have questions to Galit, then please write them as a comment into Zoom's chat function, and I will then read them, and as long as we have time for it. Okay, so now Galit, we are looking forward to your talk, and the floor is yours.
Thank you very much, Christian, and thank you, Murat. I'm trying to share my screen. Let me just, give me 1 second. Okay. Okay, can you see my screen?
Yes.
Okay, wonderful. So thank you very much for this invitation. I have to say that this is, for me, also not a very normal way to talk into my computer and just knowing that you're on the other side of your computers, but we're going to do our best here. So my talk today is about improving, notice the quote unquote, prediction of human behavior. And the quotes are there because I'm going to take you through a little journey that I discovered, which is quite alarming and quite surprising. So let me tell you a little bit about what this is. You've all probably heard of the historian Yuval Noah Harari, who's written several famous books, and you've probably read at least one of them. And in a recent TED interview, and thank you, Ron Kennett, for pointing me to this, he said the following: "The ability to hack human beings means the ability to understand humans better than they can understand themselves, which means being able to predict their choices, to manipulate their emotions, and to make decisions for them." So with this in mind, my talk today is going to talk about a combination of these things. First, I'll give you a little bit of a background about how internet platforms predict user behavior. Then I'm going to talk about how these same platforms modify user behavior. And now is going to come the interesting part that I started discovering, and this is somewhat still work in progress, but there are quite a few interesting problems here. And that is my work, where I find that you can use behavior modification to quote unquote improve prediction. So I'll show you how this might work. Then I'll show you how I use statistical analysis and where I have a challenge that requires me to include new notation, and how I use the expected prediction error, which is a very strong tool that we have as statisticians, to uncover some very alarming discovery. Okay, so part one, internet platforms predict user behavior. So before I say what these things are, I'm talking about something called behavioral big data. And this is what the companies use in order to predict our behaviors. You probably all know what big data is. We have these large data sets with many samples, many records. Maybe it's coming from multiple sources. They're very rich, they're very detailed, and they're at the micro level. When we talk about behavioral big data, we're talking about people's measurable actions, reactions, interactions, self-reported opinions, thoughts, feelings, everything that is human and social. And when you bring this together with the big data, we have these enormous data sets on large amounts of users at very micro level behaviors. We also have them coming from multiple sources. So for example, when Facebook buys Instagram, we have these connectivities, and we have a lot of data about a lot of people all the time. Now, traditional companies have been collecting behavioral big data for a long time. So if you think of the financial sector or retail or insurance, they've had a lot of behavioral data about us, and they've been using it to predict our future behavior. However, even their capabilities have gotten much stronger with the latest technologies. So if we think about now our more private spaces, like our home, and all these smart devices that we might have in our house, if you have a smart thermostat, then definitely it knows which people, who is in which room at what times and what kind of heat they prefer or they like when they're coming and going. If you have cleaning robots, they know your floor plans, and so on and so forth. If we move into another private space, which we used to inhabit a little more before the COVID, our cars. So not only do now the insurance companies know where we live and maybe where's our work and where we drive, but they know how we drive, which means we're accelerating maybe too fast when we're taking a turn. They know a lot more about our behavior and when we're getting into the car and more. Let's move even closer. Think about wearables. And when we talk about wearables, you can talk about shoes, you can talk about other clothing, and that is measuring a lot of things, not only about our locations at different times, but when we choose to use them, and even when we're near other people wearing those wearables. And move even closer, if we're wearing any of these smartwatches or fitness bands, then they're measuring lots of our behaviors, our sleeping time, of course, our pulse, but also maybe your incoming emails and notifications and your emotions in indirect ways. We also know now that children are talking to smart toys, and these smart toys are collecting a lot of very intimate information about children. So why do companies collect this data? Why do they want to predict our behavior? Well, they want to personalize and improve their products and services. They also use it for detecting fraud. They use it for advertising and marketing, and also for logistics and operations. Now come in the interesting internet platforms, and they too collect a lot of behavioral big data. If you're using any of the services that are here at the top, you know, Google, Apple, Facebook, or if you're using any of the devices that you see up here, and I'm sure you're using one of these now to listen to this conference, then your behavioral big data is being captured. And we can think about a lot more, there are many more companies that I call platforms. It can be things like online dating. It can be entertainment if you're using Netflix or you're using Spotify to listen to music. Definitely if you're using social media, all those collect a lot of information about us. And even if you're using sharing economy apps like Uber or Lyft, or you're using Airbnb, or used to use Airbnb, eBay, all these are collecting a lot of information about everything that we do. Again, why do they use it? For the exact same reasons that the traditional industries used to use them. So when we're thinking about predictions, what do they want to predict? Here are some examples of the behaviors that the platforms like to predict. Purchasing probability. What's the chance that you will purchase this item in the next week? Churn probability. How long you're going to stay on the website or on the app. Your emotional state. They can predict our emotional states pretty well now. They can predict our voting tendencies or maybe even voting behaviors. And they can even predict our life events, anything from pregnancies to job changes and more. Here's an interesting recent product that Google came out with. And this is aimed at its customers who are advertisers. And you can see that what they're selling the advertisers are likely first-time 7-day purchasers. These are predictions. So this is not who purchased in the past. This is who is likely to purchase in the next 7 days, or you can see here who's likely to churn in the next 7 days. And this is what we're going to be calling a predictive or prediction product. So what kind of efforts do these companies put into prediction, since now prediction is so important? The usual statistical and machine learning approach. We have the BBD, the behavioral big data, that includes a lot of information about the user and their profile and their behavior and their context and their friends. That's the X. And then we have the behavior that we want to predict, that's the Y. And we'll build some kind of a model, f of X, so that we can use the model to predict behaviors of new users. And that's the classic type of prediction. And the distance between our prediction, the Y hats and the Ys, is what we call prediction error. How do companies improve their prediction? Well, as we would all do, we try to build better models, whether we're using tricky new methods like ensembles. Then we collect better data. The X and the Y are the better data. And maybe we make sure that we have a strong enough computing infrastructure. And now we know a lot of people are doing very heavy computing using deep neural nets. So that's definitely 3 ways that we know how to do as statisticians. And that's also what the companies are doing. They're hiring great data scientists and paying them well. They're purchasing more and more data and companies that have data. So when Google purchases YouTube, or again, Facebook purchases other services, they're basically purchasing more data. And they're actually developing their own infrastructure that we as researchers sometimes rent and use. Okay, so now let's move away from prediction for a moment and talk about another action where platforms manipulate user behavior. What do? They want to manipulate the same kind of behaviors that I talked about a minute ago in prediction. They want to manipulate the chance that we're buying something, that we're leaving, that manipulate the amount of time we spend on the website or app. They want to manipulate our emotional states, and there have been several papers showing how they can do that. They want to manipulate, and we've seen this, how things are manipulated at the voting and political level. And unfortunately, also, this can manipulate our life events, sometimes not in good directions. How do they do this? So this manipulation is typically called behavior modification. And if you want a definition, here's a definition from psychology. This is the original field where it came from. Behavior modification is an intervention designed to enhance certainty by altering causal processes that regulate behavior. Or in short, they're modifying behavior in a predictable way. Now, there are many books now teaching companies how to do behavior modification. Here's one called Hooked by Nir Eyal, and he says the following: companies must learn not only what compels users to click, but also what makes them tick. Habits are defined as behaviors done with little or no conscious thought. So what's going on right now, if we're holding a smartphone in our hand, is that we're doing a lot of things non-consciously. You might have heard some of these behaviorist techniques, such as tuning, nudging, herding, tunneling, and conditioning. For example, if you have a phone and you have an app on it, then the choice of the defaults that the app chose, for example, notifications are on by default. That's an example of nudging. Or when you see a notification show up on your phone and you're clicking on it and it takes you right into the, whether it's an email or it's the app or the like or whatever it is, that's tunneling you right into the right place. And then we have all these mechanisms of rewards and giving us little likes or little pings or social interactions just at the right times that keep us hooked. Now, this originated again from psychology with an intention to improve human life. And then more recently, it's been adopted, these methods were adopted by behavioral economists. You might have heard of the book Nudge and Thaler and Sunstein, who use this for economic and policy engineering. And then most recently, the human-computer interaction people have taken this over, and they're the ones who are basically teaching a lot of the people who go into the large internet platforms and who start their own apps to figure out how to make these products very, very, let's just say, addictive. You can see on the right-hand side here, there's the model of Nir Eyal called the hook, how you use external and internal triggers to bring the users in, and then find the simplest actions that the user has to do so that they engage with your product. Then you give them variable rewards. You don't give them a reward every 5 minutes, but it's at random times that makes it very addictive to us. And finally, how do you get us users to just invest enough so that we don't want to move anywhere else? So these are the kinds of behaviorist techniques that are used by these internet platforms. Now, just a small notice that this type of behavior modification is really different from A/B testing, from design of experiments, and even from response surface methodology. The goal here is to optimize, for example, your time on the website. The goal is not to identify an overall optimal factors, levels, or the settings. That's not the goal. And in fact, these factors are personalized by some observed variables, such as the user's profile. And these treatments are done sequentially, deployed one after the other, as you could see in that hook model. And you can see that all these observational data are not used or to be controlled for, but in contrast, what they're doing is they're actually making use of them to personalize all these modifications. So you can personalize by the user's profile, by the context, what time it is, where they are, by their previous usage. And you can personalize all kinds of different aspects. You can personalize the stimulus, whether you're giving the person a star, or you're giving them some social pressure. You can personalize the content. You can also decide on how often they get rewards. There's a lot of personalization going on here. Okay, so now that we've talked about prediction and we've talked about modification, let me show you what happens when we put them together. So I read an interesting 2019 book by social psychologist Shoshana Zuboff from Harvard. And this book, called The Age of Surveillance Capitalism, describes exactly how the large platforms collect a lot of behavioral big data. And you can see at the bottom here, this little part here, where they're using the data for their own improvement of services. But most of the behavioral big data they collect is actually this top here, which is what she calls surplus. And Zuboff explains that this surplus is being used to sell out to other companies in the form of what's called prediction products. And these prediction products are sold in behavioral future markets. What is a prediction product? If you remember the Google predictive audiences I showed you before, where you're selling to advertisers predictions that a user will be buying something in the future, that's a prediction product. So when I read this very thick book and very interesting book, I thought to myself, wait a minute, let's see what happens. This means that the better the predictions, then these prediction products become much more valuable to these internet platforms. And then I said, okay, so how can the platforms make their predictions the most accurate that they can? Well, one approach is what we talked about before. A statistician would say, well, improve your predictive models, get better data, have sufficient computing infrastructure. And all of a sudden, a light bulb went off in my mind. And I said, hold on a minute. Because the platforms can do behavior modification, they can actually push users' behaviors towards their predictions. And what this means is that now they can do things as following. Now, before I move any forward with this, I thought at that point that this might be a little bit of a crazy or paranoid idea. So I started searching the literature to see, why would a platform even do this? And it turns out that there's a few people in some other fields, not statisticians, not technical people, who raise this issue. So for example, media theorist Douglas Rushkoff wrote a nice book called Team Human. And in it, he describes the following. The better the platform does at making Mary conform to her algorithmically determined destiny, the more the platform can boast both its predictive accuracy and its ability to induce behavior change. Then I'm looking at another field. Let's look at law. And Professor of Law Frank Pascal from University of Maryland writes in an interview for The Intercept the following. He says, Facebook's behavioral prediction work is eerie, and he worries how the company could turn algorithmic predictions into self-fulfilling prophecies, since once they've made this prediction, they have a financial interest in making it true. So this means that, first of all, a platform might have an intention to do this because they have financial incentives, and we know they do have the technical capability to do this behavior modification. Even if it's not at the management level, if we have data scientists who are under a lot of pressure to show their predictive capabilities, maybe they will start doing this. But even more likely than this is that this would already happen inadvertently, because many of these platforms use optimization algorithms such as reinforcement learning that are optimizing a certain objective function, such as time on website. And these automatically learn and manipulate and learn from the manipulation how to move forward. So let me give you two possible scenarios. And thanks, Ron, for this idea of politics. Suppose that we have a political consulting firm who wants to reach out to people who are likely to vote for Trump. And suppose that we have an internet platform who wants to sell these predicted vote for Trump scores of their users. So now the platform wants to show its predictive power. How's it going to do it? It's going to take a bunch of users, generate vote for Trump user scores, and then it's going to push the users' behaviors towards their scores. So for users who have very high scores of vote for Trump, the platform is going to push them towards voting for Trump, showing them content, befriending them with people who are maybe more in that direction. And for people with very low scores, they will push them away from voting for Trump. In other words, what we end up getting is that the platform turns voting predictions into voting realities. Here's another scenario. Suppose we have an insurance company that wants to acquire new customers, but they really want to avoid the high-risk customers. So what do? They go to an internet platform and the platform wants to sell them predicted risk scores. Suppose it's Uber or someone who can actually measure risk. And the platform's going to do the same story. It's going to generate risk scores for a bunch of its users. And then it's going to start pushing the users towards their scores. So for example, if we have a high risk person, then maybe the platform is engaging that person while they're driving, making them an even more risky behavior. In other words, the platform would turn high risk scores into high risk realities. In both these imaginary scenarios, I have no proof that they're happening. The platform is going to improve prediction in a two-step process. First, it's going to generate predictions Y hat, and then it's going to push outcomes Y towards these predicted Y hats. Let me show this to you in a more graphical way. So remember, this was the story of how a statistical or machine learning approach would go. But now what happens with a behavioral modification approach, we know that the user's mental state affects their behavior. So here comes in the behavior modification approach, where they use the platform's behavior and manipulate it so that it manipulates the user's mental state, which in turn pushes the user's behavior towards the predicted value. So now our prediction error looks much smaller and our predictions look much better. So if an internet really does this, a platform does this, a bunch of questions come up. For example, can the behavior modification mask poor prediction? Can customers infer the real predictive performance? Can a customer who's doing routine A/B testing detect this scheme? And here's another one, what's the role of personalization? These are just 4 questions and I'm gonna try and answer them. The problem is to answer these questions, I need to codify them with my statistical toolkit. So I need to represent the new scenario with a manipulation, and then I want to compute the expected prediction error under this manipulation. The tricky part is that to do something like this, I need to somehow have words for the manipulated Y. But in our world, we either have notation for prediction or we have separate notation for causal relationships, but there's no one framework that allows me to put them together in a way that's coherent that allows me to do what I'm trying to do. So here's what I did. I'm using the ordinary predictive notation to denote the prediction part. So Y given X is just a function plus some noise. And the noise has, let's say, a mean of 0 and variance sigma square. And Y hat are my predictions. F hat is my predictive function. And now I need manipulation notation. So I'm going to borrow Judea Pearl's do operator, which is very helpful here. And do of something such as do B, as you see here, means that B is manipulated as opposed to observed. So Y given the manipulated platform behavior and the observed user BBDX is going to be some function G, it doesn't even have to be X, and it's going to have some noise, and the noise also is going to be affected by the manipulation. So now I'm going to use Y tilde to denote the manipulated outcome and epsilon tilde for the manipulated noise. And you can see that the manipulated noise can have a different variance. Now I have all the notation that I need, and I can start looking at this Y tilde minus Y hat, which is the quantity that I'm interested in developing. If you remember the picture that I showed you before, the do of B is the behavior of the platform, and the Y tilde is this new manipulated Y hat. Okay, so what happens next? Without manipulation, we know the expected prediction error formula can be broken down into bias and variance. This is the well-known bias variance decomposition. With manipulation, I'm not going to show you the derivation here, but I'll show you just the result. I'm calling this EPE tilde, and you can see that I broke it down into 3 pieces. The variance part is the same as what we had before. It's affected by sample size, and you're larger the sample, you can try and shrink this here. But when you now look at the middle part, this is a little bit different, because now we have something called CATE, or the conditional average treatment effect, right here in the middle. And this conditional average treatment effect can actually help you shrink the bias if it has the opposite sign than the bias. It doesn't have to be equal to minus bias, but as long as it's countering it to a certain amount, you actually can lower the prediction error. And finally, the third interesting part here is the sigma tilde square, which is the behavior modification that can shrink potentially the variability. So we have 2 interesting levers right there. Let me show you an example of how this works. Suppose that we are Uber and we're looking at drivers who are delivering food. And suppose that I'm looking at the trip distance and then the risk as a function of the trip distance. And suppose that the true function is really something like the one that you're seeing right here. All the dots here are different drivers, so they're driving different distances and they have different risks. But suppose that I don't know the true function, so I'm going to estimate it, and I'm going to use this linear line to estimate the function. You can see that for people who ride mid-range, we have a negative bias, and for people who ride very far, we have a positive bias. So now I'm going to do my manipulation. For the people who are short range, there's no bias, so I'm not going to manipulate them. But for the mid-distance people, I'm actually going to make them a little risky by engaging them on the app. And for the people who are riding very far, I'm actually going to lower their risk by keeping them more safe. And you can see that this changes the prediction, the distance between the predictions and the behaviors. I can do an even trickier manipulation. And I can do the orange one, where now I'm not only pushing up and down, but I'm also affecting the variability. So now different risks are not only closer to the predictions, but they're also closer to each other. So this actually helps me answer the questions that we had before. First of all, can a platform mask their poor predictions using behavior modification? And the answer is yes. They can use this to counter both a bias and also shrink error variability so that things look much better than they really are. Can the customers, such as the insurance companies, infer the real predictive performance? Well, if you give me EPE tilde, can I actually find out EPE? And the answer is highly not unlikely, because you need to estimate quantities like Kate and bias and sigma square tilde. Some of them are impossible to estimate. Some of them are very hard to estimate, especially if you are not the platform itself. Our third question was, and this was Foster Provost from NYU who asked me, wait, but if a customer is doing routine A/B testing, can they detect this scheme? And the bad news is no, because they're testing for other effects. And by doing the randomization, they're actually masking the effect that the platform is doing right here. And finally, our fourth question was, what's the role of personalization? And personalization plays a very important dual role. First role, the better you personalize the predictions, the less modification you will have to do. And secondly, once you've already predicted, the better your modification is, and if you can use personalization for that, then the better your prediction product. Finally, if you're worried about the clients, such as the insurance companies or the political firms, I'm sure we're also worried about the users. So I'll just remind you that behavior modification was originally intended by psychologists for improving human life and society. But right now, if we do this combination of prediction and behavior modification, it really causes users to conform to their algorithmically determined destiny. They don't have any knowledge, or we don't have their consent. And optimizing the platform's commercial interests are really at odds with users' well-being and agency. So the question is, the statistical approach uncovered a lot of the problems here, but what do we do with this next? Who can help us bring this up and actually have an impact? To summarize, internet platforms now combine prediction and behavior modification. The imaginary scenarios that I gave you might not be imaginary, but I think that this approach is not available in our literature because as academics, we typically don't have the ability to manipulate people and predict them at the same time. This is something that only the platforms can right now do. And that's why we probably do not have the technical vocabulary to analyze the implications. And this is where I introduced Pearl's do operator. This new notation, I think, can be useful for many more types of scenarios that combine prediction and causal manipulation. One example is uplift modeling. And finally, this, I hope, is showing you the serious implications for platform customers as well as for us, the users. So I'm going to stop here and thank you very much and looking forward to the questions.
Yeah, thank you very much for your talk, for your very interesting and also very scary talk. Yeah, other questions? If you have questions, please write them into the chat and I will then read them. So it's a very long question. So here's the first question, and it is from Raffaele Vitale. And he is writing, I was wondering what might be the social or economic consequences of pushing the modifications towards completely wrong predictions. In other words, what happens if the predicted model is scarcely performant and companies push users towards wrong attitudes or behaviors?
Well, I guess this is a very interesting question. And I think it really depends on, first of all, how closely are the platforms and customers, meaning the insurance companies, how closely are their two goals? If they have the same goal, then the pushing is basically just manipulating us and it's just the users paying the price. But in the examples that I showed you, there can actually be a conflict between what the customer wants. I'm sure the insurance companies don't want to make users more risky, right? And the political consulting firm, maybe it's not even a pro-Trump firm, right? Maybe it's a anti-Trump firm, or maybe it's a nonpartisan firm. So this can be very, very extremely expensive if even the customers and the platforms don't have the same goals.
Okay, thank you. The next question, given by many questions, by Kevin Hankins, and the question is, how does this affect measurement uncertainty?
That is a really good question. I haven't thought about that. I think at this point, when we think about the level of detail and measurement that the companies have about us, even if it's wrong, we know that right now, right, there's so much data about us and there's so many predictions that lead to maybe wrong pushing of us. That's all magnified, right? So if the predictions are in the wrong direction and the modifications are in the wrong direction, everything is dramatically modified. And I think that also has to do a lot with now the new regulation of data. For example, the GDPR in the EU is probably the leader in all of this. But it's also a good question whether we want, you know, in a sense, measurement or error also protects us, because otherwise they really know everything about you.
Okay, thank you. So a lot of new messages appear in the chat, so I have to filter out where are the questions. So there's a question by Christian Ritter, and he asks, what about the impact of the GDPR in this context?
I think this is a great question. And I think, you know, right now, I'm actually doing work on GDPR. I've been doing this for a while with a few colleagues and students. And the GDPR is really regulating the data. It's just our data that it's regulating. But it allows us to opt out of algorithmic computation, right? But it's not really able to stop these kinds of manipulations, because there's currently nothing that regulates against it. And it's a really good question whether you can regulate against it. So even if you yourself opt out of algorithmic predictions, then maybe there won't be a prediction about you specifically, but your data is probably still being used to train and you know, predict other people's. So it's a really good question. I think these are great open questions about what needs to be regulated in terms of not only prediction and data, but also manipulation.
Yeah, thank you. So if I didn't miss a question, the next one is by Marco Reis, and he asks, once one interfere with a system by manipulating it towards a given goal, it becomes a control problem. The transfer function is no longer the open loop one, but a closed loop model. The effectiveness of the control is measured by how close is the observed response from the desired target. So my question is this a prediction problem or a control problem? I think this is a good, very interesting question, right?
Yeah, I think the idea of bringing in control theory in here is very interesting. The prediction is the first part. So the control would be the second part, because the prediction establishes the benchmark that you're trying to push against. But I'm not familiar very well with control theory, but I can just say one thing from, it's just a guess, it's just a thought, is that when you talk about control with humans, things might be different than when you're talking about control with machines, because closed loop is not even closed loop, it's dynamic and people change over time. And that's also why the behavior modification is not necessarily optimizing one function. It's not, it's a moving target all the time. And that's why they're using all the observational data that they have to improve the predictions. So the control keeps having to run after something that's changing all the time. But it's a great, great open question. I think this is a great new direction to bring in.
Thank you. So the questions still do not end. So you are still asked a lot. So the next question is by Chris Smerald. And the question is, it seems this can happen by design or by accident. How can this be guarded against if by accident? Is there a mapping which helps? Please. Yeah, okay.
I think that's exactly the point that I was also very alarmed about. So when I asked those 4 questions about, can you actually figure it out? Unless you're the platform, you probably cannot figure it out. And unless, I don't know, I mean, something so bizarre happens that someone will find out. I think this is happening, and I personally believe it's actually already happening because of reinforcement learning being run all the time. And I think only the platforms can potentially find it out, but I don't even know how they can find it out. And in that sense, I think that there's a big danger of allowing the same entity to do the predictions and to do the manipulations. It's too much power that, again, can just go out of control very fast.
Yeah, right. In this direction is the question, if it is a question, or maybe it's more thought as a comment by Christian Ritter, who asks, should this be called fraud or criminal interference?
I'm glad you're using those words, because I personally also feel very strongly about this. I don't know how many people in here are from marketing, but maybe in marketing it's not considered fraud. It's a good question. I think this is at the level of, it's much worse than subliminal advertising. I think this is really dangerous manipulations. I think this is, you know, if things are gone crazy up to now, this is like upping it one step further. And that's why I was very alarmed when I thought about this combination and started quickly trying to see if anybody's talking about this anywhere else. And I was, you know, relieved, but not relieved to see that I'm not just imagining this possibility.
Okay, thank you very much. I think looking at the clock, we have to stop here with questions. So let's thank you again for this very, very interesting talk.